everyone. Hopefully you're having a good start to your week this Monday morning. Good bit of news. This is going to be the only video for this week. We're only going to do one video. We're going to talk about binomial expansion. You've got 2 Excel assignments, or if you're doing the paper-based assignments, you have 2 worksheets, and that's it for the whole week. So let's get right into it and get over with this video. I'm hoping to be done as quickly. It should be short, but we'll see how it goes. So first thing, when we talk about binomial expansion, this is a topic we've already covered, but this is another review week for us, so I want to make sure that we cover anything that we need to work on. Binomial definition is a polynomial with 2 terms. I'm going to give you a few examples of what that looks like, since you're going to be seeing a whole bunch of them. Is we could say something like 2x minus 1. That's a binomial. We have 2 terms. Remember that terms are always separated by plus and minus symbols. I could say that's not a very good a plus b. A plus b is a binomial. Could say 3a minus y squared. That's a binomial. It doesn't matter what the powers are. I could say it's x to the 5th minus y to the 7th. That's still a binomial, because the definition has to have 2 terms separated by plus and minus symbols. Okay? Most of the binomials you're going to see, at least for this video and the assignments that you have, are going to look like this and this. These are the 2 we're going to be kind of focusing on. No really powered ones right now. Right. Another thing we need to talk about, we talked about this already, let me scroll down first, is we need to talk about Pascal's triangle again to make sure that you understand how to form the triangle. Remember that the very top box is a 1, and every box going down the left-hand side and the right-hand side are all 1s. Okay, so there's all my 1s. Your job is to fill in all the stuff in the middle. And it's not difficult to do. Remember, it is each box. So if we're talking about this box right here, each box is the sum of the 2 boxes that are directly above it. Therefore, if I want to fill in this box, I'm going to add up these 2 boxes above it. 1 plus 1 is 2. There, I've completed that row. If I want to fill in this box, well, I need the 2 boxes above it. That's 1 and 2. I add them together. That makes the number 3. Right here, 2 and 1, we add them together. That's 3. And we can continue this pattern all the way down the triangle. We're going to do a few more, and then after that, you're not going to need really anything down here. Most of the ones that you're going to be doing today and on your assignment, I don't believe, go above the 7th power. So we're going to fill in until we get to the 7th power. Okay, so we continue working. This box is 1 and 3. That's 4. 3 and 3 for this box. That's 6. And this box is 3 and 1. That's 4. At some point, the pattern replicates. You notice it's 1, 4, 6, and then it goes back to 4 and then 1. It replicates on the other half. So here, we've got 5. So that's 1 and 4. And then we have 4 and 6 makes 10, and then watch what happens. 6 plus 4 is 10. There's the replication. 4 and 1, 5. 1, 5, 10, 10, 5, 1. It replicates going the other way. All right, I'm going to go ahead and fill in the rest of these real quick, since I think you got the idea. 15, 20, 15, and 6. Here we have 7 and 21, 35, 35, 21, and 7. I'm just going to fill in the 8th row just in case. 8, and we have 28. Here we've got 56, 70, 56, 28, and 8. As I said, you can continue, but we really are not going to be using these down here. Because notice what these are going to tell us is the number of terms in the polynomial that we're expanding to, and it's going to tell us the coefficients. So if I'm down here at this 8th one that I put the arrow on, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. That means that I would have a polynomial, and this is just an example. It's not going to be exact, but we'd have like x to the 9th, x to the 8th, x to the 7th. That was a lambda. X to the 6th, x to the 5th, x to the 4th. That's 1, 2, 3, 4, 5, 6. Actually, this should be an 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. This is how long that polynomial could be. Now, of course, it could not always be 1 in the front. Clearly, we're going to have different numbers based on this triangle. But this is the length of the polynomial we'd be talking about if we tried to expand, let's say, x plus 1 to the 8th power. That's how many terms I would have. That takes a lot of time. Okay, and so I'm not going to require you to go that in depth. I think the highest one, like I said, I remember being is a 7, just so you see the 7 one time. So why are we going to use Pascal's triangle to expand the binomials? What's the point? Well, I want to show you. I'm going to bring up a new page. I'm going to show you the reason why we do Pascal's triangle. I'm going to put the triangle that we're going to need over here. That's far enough for the problem we're going to do. If I gave you this, a plus b cubed. Well, right off the bat, we know what a plus b cubed means. It means a plus b multiplied by a plus b multiplied by a plus b, or multiplying a plus b 3 times. We know that's what this is telling me to do. So in a normal sense, before I know Pascal's triangle, you would say, okay, I need to multiply these two together, so let's do that now. A times a, that's a squared. A times b, that's ab. Then we do a b again. B times a, I'm going to keep them in a and then b order, so ab. And then b times b, that's b squared. And we always try to combine any terms that we can. So I can combine these two. Okay, so I've simplified now, but I've FOILed these out, but I've still got this one to deal with. So I've got to bring it down. And now I've got to perform multiplication again. That doesn't look a very good A. There we go. Now I've got to distribute a squared to both, 2ab to both, and b squared to both. So let's do that now. So a squared times a is a cubed. A squared multiplied by b is a squared b. Now I got to do 2ab. I'm going to do a different color just so we can see the difference. And I'm going to write them below. I'm going to line up the terms that match so I can just add going down. So 2ab times a. That's 2a squared b, because a times a would be a squared, the b would be attached on the end, and the 2 in the front. 2ab multiplied by b. Well, the b's are going to multiply together and make b squared, and we're going to write everything else as a list, so 2ab squared. And we still got to multiply again. B squared times a is ab squared. And finally, the last multiplication, b times b, b squared times b is b cubed. Well, now, since I've got everything lined up, I can add everything going down. There's nothing to add with a cubed, so it stays the same. A squared b plus 2a squared b, that's 3 of them. Remember, this has got like a 1 in front. 2ab squared and 1ab squared. Well, 2 plus 1, that makes 3 of those. And there's nothing to add with b cubed, so we just leave it as it is. And this would be our polynomial that we would expand. Now, this, just in my opinion, all this up here, that's a lot of work. Okay, that's a lot of work to have to try to do to get to expand one thing. Imagine this number being a 5 or a 7, or in worst case scenario, what we were talking about with the 8. Imagine this being the number 8 and having to do this with 8 of these binomials. I don't want to do that. I shouldn't have to do that, right? So what we're going to do instead is I'm going to show you how to use Pascal's triangle to do the same thing. And since I've scrolled down, I have to put my Pascal triangle back. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, so I'm talking about a plus b cubed. We're not going to change that. And yet again, we're still talking about a plus b times a plus b times a plus b. Okay, we want to multiply these together, but we don't want to do all of that work that we had to do. Well, what we do is the first thing we're going to look at is we're going to look at this number right here. That number 3 is going to tell me what row in Pascal's triangle I need to use. I'm looking for the row in Pascal's triangle that has 3's in it. Well, that's this row right here. This row has 3's in it. And so now that I know that this row has 3's in it, I'm going to do the setup for Pascal's triangle. Now, initially, this setup is going to take a little bit of work, a little bit of time, but once the setup is done, the multiplication stuff is easy, and you're going to have your answer in less steps. So the first thing I'm going to do now that I know it's that, I know that there are 1, 2, 3, 4 terms. So this tells me number of terms. This also tells me the numbers or the coefficients. At least initially, it tells me the coefficients for the number terms. So I'm going to write these out. 1, and I'm going to put a little blank because I'm going to fill some stuff in. Okay, so I've got my setup done. The only thing I have to do now is fill in my A's and B's. So I'm going to put A's and B's in parentheses in every blank. Okay, now I've filled in my A's and B's. Next thing I want to do is, starting with the letter A, I'm going to start with this number 3. I'm going to make it an exponent. And I'm going to go with every single A going down, but every time I'm going to take 1 away. So if I start with 3, this A is going to have a 2. I take 1 away, go to the next A, that one's only got a 1. I take 1 away, go to the last A, it has a 0. Now I'm going to do the same thing, but I'm going to start at the back and work my way to the front. So B has got a 3, and every time I jump to a new B, I drop by 1. So 3, jump to the next one, drops by 1 is to a 2. Jump to the next one, drop by 1. And finally jump to the last one, and it's a 0. You are now done with the setup. It has been set up. All you have to do now is just simplify. First thing I will say is that any of them with zeros, I'm going to go ahead and mark them off. Because anything, we know that anything to the 0 power is 1. Well, 1 times anything is just whatever's there, so we don't even have to worry about anything with zeros. Now let's simplify. A cubed times 1. Well, that's A cubed. Then I've got 3 times a squared times b. Then, on this last one, this next one, 3a to the first b squared. And the last one, 1, this one didn't matter, 1 and then b cubed. There's the answer. Now if we look back, here's this answer. I'm going to zoom up just a little bit so you can see the other one. These are the exact same. But look at the amount of work I did here versus the amount of work I did here. Much simpler. So we're going to be using Pascal Triangle whenever we expand these binomials, just to make it quick, easy. Okay, so let's move on down. So I've got some problems, and I've put a little Pascal Triangle here, just so that way we'll have it as a reference, so that we don't have to keep drawing it every single time. And then I've also got some U-try problems down here at the bottom. Notice that on my problems, I don't go anything higher than the 5th power. Okay, because I think that once you do enough of these, it won't matter what the power is, you'll be able to do it regardless. So I'm going to start with number 1. And to not make this video super long, because we're already at 16 minutes, is I'm going to do the setup quickly and then do the multiplication, but I'm going to spend a lot more time on 2 and 3 because, as you notice, they've got different numbers than just an x and a y. Okay, so ones like 1 and 4, I'm not going to spend a lot of time on because I think you can do those really quickly. So I'm going to do the setup looking at rows with the number 4. So that's this row right here, 1, 4, 6, 4, 1. Fill in my x's and y's. And then start with the number 4. And every time I jump in x, I drop 1. And I'm going to go ahead and mark off any of them that become zeros. Start at the end and do the same thing going backwards. 4, 3, 2, 1, 0. And now let's write out the answer and do our multiplication. 1 times x to the 4th is just x to the 4th. 4 x cubed y. 6x squared y squared. 4xy cubed. And 1y to the 4th. I want you guys to notice these right here. Now I'm going to add in, though we normally don't write the numbers. If they're ones, I'm going to write them in real quick just so you see something. Make sure when you're going through this is your check to make sure you've got the right powers. This is a 4. These 3 and 1 make 4 if you add them up. 2 and 2 make 4 if you add them up. 1 and 3 make 4 if you add them up. And there's a 4 at the end. Each of these sets of powers should be the same. Even if there's 2 of them, they should add up to be the same number. Therefore, 4, this is 4, 4, 4, and 4. All those exponents make the number 4. Okay, that's your check to make sure your exponents are correct. All right, looking at number 2. Number 2 is a little different. I'm looking row with the number 3s. So I already know I'm going to have a 1, a 3, a 3, and a 1. All right, fill in, just like we did x's and y's, we're going to fill these in. You do have to keep the signs. At least for the way that I'm doing this technique, you're going to keep the signs. So 2a and negative b. So same thing. We haven't changed any of the process. We're still going to start with the number 3, with the 2a, with the first variable set, and work my way down. And I'm actually going to change the color real quick. Hold on. So we've got a 3, then a 2, then a 1, then a 0, mark them off. All right, starting from the back, 3, 2, 1, 0, mark it off. Okay, here's where the simplification gets a little different. Now I've got 2a to the third power. So over here, just to show you what that means, it's similar to what we talked about earlier with the binomial, is that I'm talking about 2a times 2a times 2a. Okay, so that means I've got to multiply 2a by itself 3 times. So 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. A times a times a is a cubed. Here's where the most common, this is the most common error, is people say it's 2a to the third. Because all they do is apply the 3 to the a and say, oh, I'm done. Please do not make this error. Multiply them out. Take that exponent, give it to both of them on the inside of the parentheses. So this one's going to have one extra step because I'm going to have 2 multiplications to do. So I'm going to go ahead and write them out. I've got this 1, it comes down. And we know that 2a cubed is a to the 8a cubed. All right, plus, I'm going to bring my 3 down. Now I've got 2a squared. Well, 2a squared is 2a times 2a. So take my 2, give it to both. 2 to the second power is 4a, and then squared. And then I have negative b to the first. So nothing changes. Bring my 3 down again. 2a to the first power, so nothing changes. And then negative b squared. Now that one we need to talk about as well. Remember, that's going to be negative b times negative b. Well, a negative times a negative is a positive. B times b is b squared. Yet again, that common error, people are going to say, oh, it's negative b squared, and that's wrong. All right, and the last set, we already crossed out 1. We've got the 1, and we've got negative b cubed. Well, negative b cubed, there's 3 of them now. A negative times a negative, that makes another negative. B times b times b is b cubed. So this is 1 and then negative b cubed. Now, final simplification, so we can be done with this problem. We just multiply what we have in parentheses together. 1 times 8a cubed is just 8a cubed. 3, and I put a plus when I shouldn't. 3 times 4 times negative 1, well, that's negative 12. A squared b. So see what I did? I did 3 times 4 times this negative, and if it's just negative, we say it's negative 1. So I multiplied those 3 numbers to get my negative 12, and then wrote my variables, a squared and b. All right, this one doesn't have any negatives, so it's safe to put a plus. 3 times 2 times 1, so 3 times 2 is 6, times 1 is still 6. Write my variables, a, b squared. And last one, this one is negative, so 1 times negative 1 is negative, and then b cubed. And there is my answer. Notice the pattern, positive, negative, positive, negative. So there is a pattern to this. Okay. Number 3, we've got 3w plus 2 to the 4th power. This time we don't have another variable. It's just a number, which means that we're only going to have w's going through. 4th power means I'm looking for a row with a 4. So 1, 4, 6, 4, and 1. All All right, fill them in. So 3W and the number 2. Okay. And just as we've done every single time, we start with the number 4 and work our way down. Actually, can I do this in red again? So 4, 3, 2, 1, 0. Mark off the 0. Going backwards, same thing. So 4, 3, 2, 1, 0. All right. So I've got to do 3W to the 4th power. So 3 to the 4th power, so let me bring down my 1 first. 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. W to the 4th. And then we don't have anything there. We have a 1. Here I've got 4. 3 cubed. So 3 times 3 is 9, times 3 is 27. W to the 3rd. And I have the number 2. Here, go to 6. 3W squared, so 3 times 3, that's 9. And then W squared. And then 2 squared, that's 4. Here, we've got 4. 3W to the 1st power is just 3W. And 2 cubed. 2 times 2 is 4. Times 2 again is 8. And the last set, I've got 1, and I've got 2 to the 4th, which means really it's just 8 times another 2, which is 16. Simplifying it out, multiplying anything we had to multiply here, that's going to be 81W to the 4th. 4 times 27 times 2. That's 216. And then I have W cubed. Here, 6, 9, and 4. Multiply those together. I get 216 again. W squared. 4, 3, and 8. That's 96. W. And then I have 16 at the end. Now, this is not always going to be the case. These two are not always going to multiply and come out to be the same. Okay. Other thing, the trick I showed you earlier about adding exponents only works if there's multiple variables. Notice here it's 4, 3, 2, 1, none, which makes sense because I only have one variable. So that is the only thing that should have an exponent going down. Okay, but it does match up here if you want to look back. 4 and 0 is 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, 0 and 4 is 4. So it did work, it's just that the number gets incorporated in when you multiply at the end. All right. Number 4. Now, number 4, I'm just going to write you out the answer to number 4 because it's kind of long and our video is already at about 30 minutes. So let's go ahead and write this one out. It's going to be x to the 5th minus 5x4y plus 10x3y squared minus 10x squared y3 plus 5xy4 minus y to the 5th. Okay. Notice that we're using this row 1, 2, 3, 4, 5, 6 of them. 1, 2, 3, 4, 5, 6. 5th power. Got a 5 in the front, 5 in the back. All of them in the middle add up to be the number 5. And we've got that pattern thing again because we switched from having just plus to a minus. Positive, negative, positive, negative, positive, negative. That should happen. Okay, so there's your answer. All right, so at the bottom, you got a couple of U-try problems. I'd pause the video now and go ahead and try these out, and then come back when you're done. Okay, so I'm assuming that you have paused the video and have come back to check your work. And so, which means I'm just going to write out your answers here so you can see them, and we're going to call it a day. So, d plus h to the fourth, answer being d to the fourth. Actually, I'm going to just do it up here, that way we can see it. So here's number 5. It's going to be in the black marker. So I've got d to the fourth plus 4d cubed h plus 6d square h square plus 4dh cubed plus h to the fourth power. Okay, number 6. Do number 6 in the blue. So number 6, I'm going to have, find my notes. Okay, so here's your number 6. I've got x to the 5th minus 5x to the 4th plus 10x cubed minus 10x squared plus 5x minus 1. And lastly, in the red, number 7, I've got 8x cubed minus 36x squared y plus 54xy squared minus 27y cubed. Okay, so there's our 3 answers, 5, 6, and 7, each color-coded for you. Last thing I want to talk about real quick, and then we're going to be done for the day, is that there's a variety of questions that can be asked for these kind of problems. They could ask you, expand the binomial, which is what you have done in every problem that we've done today, is just write out the whole answer. They can say, for example, let's look at number 7 specifically and say, what is the second term? What if they ask me for second term? That means all they want as the answer is just this right here. They could ask me, what is the coefficient of the last term? Okay, that is just this negative 27. All right, they could ask me exponents of third term, which means that I would need to give them this right here. Or they could just say, as I've said before, expand, which would mean the whole thing. Okay, so there's 1, 2, 3, 4 different kinds of questions that they could be asking me on these problems. Okay, all of it is just different parts of the same answer. Okay, with that, guys, that's going to be it. We're at about 35 minutes for the video. Sorry it took so long, but there's a lot of meat to these. Make sure that you are getting in contact with me if you are having any kind of difficulties, if something's not working out, if you're needing to talk about extending homework or anything like that. Feel free to message me, email me, Parent Square, Student Square, Remind. If we need to set up a Zoom and do one-on-one together, we can do that. There's a lot of options open to you guys right now, so make sure that you get in contact so that way we can set up whatever you need. And it doesn't matter what time. I've had people call me at 7 o'clock, 9:50, 10 o'clock. It doesn't matter what time. If you're working on it and I'm awake, send me a message, let me know, and we'll work on it. Okay? So with that, I'll see you guys in another video, or I'll wait your emails.